two terms. So we will get here 0 to 5 cube root of x plus 2 plus cube root of 7 minus x upon cube root of x plus 2 plus cube root of 7 minus x dx, and that is equal to, we know that both are numerator and denominator are equal, so we will get 0 to 5 1 dx. Okay, so I plus I, so we'll get I plus I, that is 2I is equal to integration 0 to 5 1 dx. Okay, and the integration of 1 is equal to x with the limit 0 to 5 is equal to 2I. So we will get 2I is equal to 5 minus 0, the upper limit 5 minus lower limit 0, that is equal to 5. So I is equal to 5 by 2. This is the solution of this kind of example. So this rule which we have used in the starting is very important. I want to again remind you that 0 to a fx dx is equal to 0 to a f of a minus x dx, and by using this rule we can get the two expressions of I, two equations with I. This is the first one, and the second equation with I is this one, and by taking the addition of 1 and 2 we will easily get the integration of I plus I, that is equal to 2I is equal to integration of 1, that is equal to x, and by integrating that we will get I is equal to 5 by 2. So in this way we can solve the example of that kind. So this is the second example of example number 4b. Now the third example of 4b. Okay, question is find the area bounded by the curve y is equal to x square minus 7x plus 10 and x axis. Okay, we need to, this is the application of integration. Find the area bounded by the curve. First we need to draw the diagram, and before we draw the diagram we need to find the crossing point of this one. So first if we draw the diagram, then here when x axis, on the x axis y is equal to 0, so if we put y is equal to 0 here, then we will get x square minus 7x plus 10 is equal to 0, because we need to find the area bounded by the curve, this one and the x axis. On the x axis y is equal to 0, so I want to find the crossing point of this curve and x axis. Okay, so I put y is equal to 0 in this one, so we will get x minus 5 x minus 2 is equal to 0, because minus 5 into minus 2, that is plus 10, and minus 5 minus 2, that is equal to minus 7. So we will get x is equal to 5 and x is equal to 2 on the x axis, right? So the points on the x axis, so the points on the x axis are, first one is 2, right, and the y is 0, so the first point is 2 0 and the second point is 5 0. These are two crossing points of these curve and x axis. Now let us try to draw the diagram of, and then I will get the area bounded by the curves. So here if I draw the diagram here, this is x-axis, this is y, this is 0 0. Okay, here 0 0. The first crossing point is 2 0. If here is 1, here is 2, so this point is 2 0. Okay, then this is 3 4 5, so this point is 5 0. This is 2 0, this is 5 0, and this is the equation of parabola. Okay, so this is the parabola of like this. Okay, this is the parabola like this, and the area enclosed between x-axis and this parabola, that is, okay, so here we want to find the area of this part, which is I have drawn by the cross lines. This is the area bounded by this curve, which is y is equal to x square minus 7x plus 10, and by the x-axis. Okay, so we want to find the area of this curve, and area A is equal to, okay, area A is equal to integration over 2 to 5 pi integration over 2 to 5 y dx. Okay, so that is equal to pi, y is equal to x square minus 7x plus 10 into dx with the limit 2 to, here there is 2 0. Okay, so this is from 2 to 5, right? So by integrating this one, we will get A is equal to pi, again I am writing the same step, 2 to 5 x square, 2 to 5 x square minus 7x plus 10, right, into dx. So this is pi integration of x square, that is x cube by 3 minus 7x square by 2 integration of, that is x square by 2 plus 10x with the limit 2 to 5. This is equal to pi. First I will put the upper limit. This is 5 cube, that is 125 by 3 minus, this is 5 square, that is 25, and 25 into 7, that is 175 by 2. Okay, because 5 square, that is 25, into 25 into 7, that is equal to 175 upon 2 plus 10 into 5, that is 50. This is the upper limit, minus, if I put the lower limit, 2 cube, that is equal to 8 by 3 minus 2 square, that is equal to 4 upon 2, that is equal to 2 into 7, that is 14. Okay, and plus 10 into 2, that is equal to 20. Okay, so this is the upper limit, this part is lower limit. So after the simplifying, we will get here the LCM is 6, so I will multiply this with 2, so I will get 250 minus, I will multiply this with 3, so I will get 525. Okay, 175 into 3, that is equal to 525 plus 50 into 6, that is equal to 300. Divide by 6 and minus here, this is 8 minus 14 into 3, that is 42, plus 60 divided by 3. So this is equal to pi 300 plus 250, that is equal to 550. 550 minus 525, that is equal to 25 by 6. Okay, and minus we will get here 60 minus 42, that is equal to 18, and 18 plus 8, that is equal to 26 by 3. So I will get pi into 25 minus 26 into 2, that is 52 divided by 6, and we will get minus 27 pi by 6. And the area is never be negative, so I will put area in the modulus, so we will get 27 pi by 6. So our answer is 27 pi by 6, right, which is the area bounded by the curves. Area which is bounded here, the area is equal to, area of this part is equal to 27 pi by 6. Okay, so in this way we can find the area of enclosed region between any two curves. So this is the end of question number 4. We still remain to solve the question number 5 of this exam paper, but this session is going to finish, so we will solve the question number 5 of this exam paper next time. So that's it for this session. So please try to remind all the formulas of integration and differentiation first to solve the example of integration and differentiation, as well as the main theorems of differentiation, like the multiplication rule, the division rule, chain rule. In the integration, the method of integration by parts, the theorem that we have shown in this example, that is integration 0 to a fx ds is equal to integration 0 to a f of a minus x into dx. All these kind of examples, all these kind of theorems need to remember by all the students to solve any exam papers. So by remembering all kind of these formulas and and the theorems, we can easily solve the question paper. તો બધા વિદ્યાર્થીઓને એ જ સૂચના છે કે બધા વિદ્યાર્થીઓ ઇન્ટિગ્રેશન અને ડિફરન્સિએશનના ફોર્મ્યુલા ખાસ કરીને યાદ કરી લે, અને ખાસ કરીને મેન એની જે મેથડ્સ છે, ટેકનિક્સ છે. ફોર એક્ઝામ્પલ આપણે આજે મેથડ ઓફ ઇન્ટિગ્રેશન બાય પાર્ટ્સનો યુઝ કર્યો, મેથડ ઓફ ઇન્ટિગ્રેશન બાય પાર્શિયલ ફ્રેક્શન મેથડનો યુઝ કર્યો. સેમ રીતે આપણે ડિફરન્સિએશનની અંદર પણ ઘણા અલગ અલગ પ્રકારના ડિફરન્સિએશનના મેથડ્સનો યુઝ કરેલો છે. તો આ બધી જ મેથડ્સ અને બધા જ ફોર્મ્યુલા બધા વિદ્યાર્થીઓએ યાદ કરી લેવા, કે જે તમને એક્ઝામમાં ખૂબ જ કામ લાગશે. તો હજી આપણે ક્વેશ્ચન નંબર 5 સોલ્વ કરવાનો બાકી છે, કે જે આપણે નેક્સ્ટ ટાઈમ સોલ્વ કરશું, કે જે ડિફરન્શિયલ ઇક્વેશનના સોલ્યુશન ઉપર છે. So we will solve it in next session or next time when we will meet. So thank you very much for these 3 sessions. Thank you very much.